Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the relationship between rational exponents and nth root radicals. Before we do, let's start with a definition. If we have x to the m over n power, that is equivalent to the nth root of x to the m power. So, for example, let's say we had 8 to the 2/3 power. Our denominator is a 3, so we could rewrite this expression as the cube root of 8 to the 2 power. Or we could rewrite it like this, cube root of 8 to the 2 power. So we know cube root of 8 is 2, and 2 to the 2 power is 4. So 8 to the 2/3 power is 4. Let's say we had, let's see, I don't know, 16 to the 1/4 power. Our denominator is 4, so we could rewrite this as the 4th root of 16 to the 1 power, which is the same thing as 4th root of 16 to the 1 power. Now, the 4th root of 16 is 2 to the 1 power, which is simply 2. So 16 to the 1/4 power would be 2. All right, example 1. Convert each expression written in rational exponent form to an expression written in radical form. Simplify if needed. All right, so in problem A, we have x to the 1/5 power. So what I want you to notice first is the denominator is 5. That means we're going to use a 5th root to rewrite this expression. So this would simply be the 5th root of x to the 1 power. Now, when we have a power of 1, we don't usually write it. So for your final answer, I'd like you to just rewrite this as 5th root of x. Now, we cannot simplify this any further because there's just one x as our radicand. So this would be your final answer. X to the 1/5 power is the same thing as the 5th root of x. All right, problem B. We have 7a to the 1/2 power. So this time our denominator is 2. So that means we'll use a square root to simplify this. So this would simply be square root of 7a. And because it's to the 1 power, I'm not going to even write the 1 power. Okay. Problem C, 24 to the 1/3 power. So this time our denominator is 3. So that means we're going to use a cube root to simplify this. So this would be cube root of 24 to the 1 power. But I'm not going to write the 1 because 24 to the 1 is still 24. Now, this expression can be simplified if you remember what you learned about simplifying nth root radicals, because 24 could be broken down into a perfect cube factor. So we could rewrite 24 as cube root 8 times cube root 3, because 8 times 3 is 24. So hopefully you remember that the cube root of 8 is 2, cube root 3, and this will be our final answer. All right, pause the video and try problem D on your own. All right, welcome back. Hopefully you used a cube root to simplify this. So this would be the cube root of 5 to the 2 power, which could also be written as cube root of 25. Now, we cannot break 25 down because the factors of 25 are 1 in 25 or 5 times 5. None of those numbers are perfect cubes, so let's just leave it right there, cube root 25. All right, here, next problem, problem E, we have a to the 7/2 power. So our denominator is 2, so we're going to use a square root. And our numerator is 7, so we will use our 7 power. Now, this can be simplified. Because this is an index of 2, we can rewrite this as the square root of a to the 6 times the square root of a to the 1. 6 plus 1 giving 7. All right. Now, remember when you're simplifying square roots, you're going to take your power, 6, and divide it by your index, which is 2. So this would be a to the 3 times the square root of a. All right. Problem F, we have 27x raised to the 1/3 power. So we have a denominator of 3. So we're going to use a cube root here to rewrite this. 27x to the 1/3 power is equivalent to cube root of 27x. Now I can simplify that because I can rewrite this as cube root 27, that's a perfect cube, times cube root x, that is not a perfect cube. So the cube root of 27 is 3, and we can't do anything to cube root x. So that's as far as we can simplify it. All right, problem G, we have xy to the 7/2 power. So our denominator is 2, so we'll be using a square root. So this would be the square root of xy to the 7 power. So we could rewrite that as the square root, the square root of x to the 7, y to the 7. Now we can simplify that by taking out the perfect squares, x6, y6, times the square root of just xy. So take your 6, your power, divide it by 2. So this would be x cubed, y cubed, and then square root xy. All right, problem H, we have 4 times the quantity 3a to the 4/3 power. Now what I want you to notice here is this 4 is not inside the parenthesis. So we're going to take the 4, it'll be in front, and then we're going to rewrite this expression right here as a cube root. Okay, so this would be 4 times the cube root of 3a to the 4th power. Okay, so that would be the same thing as 4 times the cube root of 3 to the 4 times a to the 4. Now, we can simplify this a little further because the exponent is larger than the index. So that means I can rewrite this as a product of perfect cubes. So this would be 4 times the cube root of 3 to the 3 times a to the 3 times cube root of 3 to the 1 a to the 1. All right, so this would be 4. Now, the cube root of 3 to the 3 is just 3. The cube root of a cubed is just a. And then here we have cube root of 3a. Now, I still need to simplify a little bit more. 4 times 3 gives me 12. 12 times a gives me 12a. So this would be 12a times the cube root of 3a. All right, example 2. Convert each expression written in radical form to an expression written in rational exponent form. So in problem A, we have the cube root of 15. Now what I want you to notice is this is an understood power of 1. So we could rewrite this as 15 to the 1/3 power. Remember, your root, whatever your root is always going to be your denominator. Okay. Problem B, we have the square root of AB. So this is an index of 2. So our denominator is going to be 2. So this will be AB to the 1/2 power. Okay. fourth root of 3x. So this time our index is 4, so that's going to be our denominator. So this would be 3x to the 1/4 power. All right, pause the video and try problem D on your own. All right, welcome back. Hopefully you rewrote this as a to the 2/3 power. All right, next problem we have the square root of 5m to the 9th power. So our index is 2. So to rewrite this, we would take 5m to the 9/2 power. All right, problem F, we have the fourth root of negative 2w to the 5th power. So our index is 4, so that's going to be our denominator. So this would be negative 2w to the 5/4 power. All right. Problem G, we have the square root of 10 to the 5, a to the 3 times b. So to rewrite this, this would be 10 to the 5, a cubed b to the 1/2 power. All right, try problem H on your own. All right, welcome back. Let's see, I rewrote this as 9x to the 7, y to the 4, raised to the 1/3 power. Now, in our next set of problems, we're going to simplify expressions with rational exponents, and we're going to follow these steps. First of all, if you have a radical, not all the problems will have radicals in there, but if they do, you want to rewrite them first in exponential form. Secondly, use the exponent rules to simplify your expressions. And step 3, write your answer as a radical in simplest form. So for example, in problem A, they want us to rewrite each of the following in simplest radical form. So in problem A, we have x to the 1/3 times x to the 4/3. So step 1 says rewrite all radicals in exponential form. Well, in problem A, we don't have any radicals. So step 1 is already done for us. So step 2 says use the exponent rules to simplify the expressions. Now, I'm going on the assumption here that you already know your basic exponent rules. I'm not going to teach those in this lesson. I will, however, be using the calculator to work with fractions, just so we don't let the arithmetic get in our way of simplifying the radicals, all right? So we have x to the 1/3 times x to the 4/3. So remember, when you're multiplying like bases, you're going to add the exponents. So this is x to the 1/3 plus x to the 4/3. So if I add 1/3 and 4/3, I get x to the 5/3 power. Now that's not your final answer. Look at step 3. Write your answer as a radical in simplest form. So to write my answer as a radical in simplest form, I would notice that my denominator is 3, and I would use a cube root to simplify this. So this is the cube root of x to the 5 power. All right. In problem B, we have a to the 1/4 times a to the 3/2. So we have like bases, so we can add our exponents. So this would be a to the, and I'll just use my calculator, 1/4 plus 3/2. And then turn that into a fraction, and that gives me to the 7/4 power. So I did step 2. I used the exponent rules to simplify the expression. Now we're ready for step 3. Write my answer as a radical in simplest form. So my denominator is 4. So I'm going to rewrite this as the 4th root of a to the 7 power. Now, I know this can be simplified because my power is larger than my index. So to simplify this, I need multiples of 4. So I could rewrite this as the 4th root of a to the 4 times the 4th root of a to the 3, because 4 plus 3 gives you a power of 7. Now the 4th root of a to the 4 is just a. And then the 4th root of a cubed will not simplify. So a times the 4th root of a cubed. All right, in problem C, we have a to the 5 over 2 divided by a to the 7 over 4. So remember, when we divide like bases, we subtract the exponents. So I could rewrite this as a to the 5 over 2 minus 7 over 4. So just reviewing your exponent rules. When we divide like bases, we subtract the powers. So this would be a, and I'll just use my calculator here to simplify this. I do not want the arithmetic of fractions to hold you back on learning the exponent rule. So 5 over 2 minus 7 over 4, and then turn that into a fraction. So this would be a to the 3/4 power. Now, step 3, write your answer as a radical. So my denominator is 4, so I'm going to use a 4th root to simplify this. So this would be the 4th root of a to the 3 power. Now, what I want you to notice on this problem is the exponent is smaller than the index. The exponent is smaller than the index, so we are not going to be able to simplify this any further. So final answer on this one would just be 4th root of a cubed. All right, problem D. We have m to the 1/3 power raised to the 5 over 2 power. So hopefully you remember from your exponent rules, to raise a power to a power, we multiply the exponents. So this would be m to the 1/3 times 5 over 2. So that would be m to the 5 over 6 power, and then rewrite that as a radical. So this would be the 6th root of m to the 5, and it will not simplify. All right. Problem E, we have 8x squared to the 2/3 power. So this would be, if to raise a power to a power, I multiply this. So this would be 8. Well, I'll tell you what, let's break this apart. This would be 8 to the 2/3 times x to the 4/3. So this would be the same thing as the cube root, because our denominator is 3, of 8 squared times x to the 4. Okay, cube root of 8 squared times x to the 4, which is the same thing as cube root of 64 x to the 4. Now, this can be made up and simplified a little further because this power is larger than this index. So I'm going to rewrite this, and I'm going to break out the perfect cubes. So this can be rewritten as cube root of 64x cubed, those are perfect cubes, times the cube root of x to the 1. Now, the cube root of 64x cubed is just 4x. And then we have cube root x. Final answer. All right, now problem F. This is the first problem we've encountered in this set of exercise that have radicals. So we're going to have to go back and look at step 1. Rewrite all radicals in exponential form. So the cube root of x squared could be written as x to the 2/3 power. And the square root of x could be written as x to the 1/2 power. Now this problem becomes just like problem A. you're going to use your exponent rules to simplify this. So I'm going to take 2/3 and I'm going to add 1/2. And that would be x to the 7/6 power. So this would be the 6th root of x to the 7 power. Now this can be simplified by rewriting as x, the 6th root of x to the 6th power times the 6th root of x to the 1 power, because 6 plus 1 is 7. So 6 divided by 6 just gives you x, and then we have 6th root of x. All right. Pause the video and try problem G on your own. All right, welcome back. Hopefully you began by rewriting this as r to the 3/4 power times r to the 1/2 power. Now, 3/4 plus 1/2 gives me r to the 5/4 power. To rewrite that as a radical, this would be the 4th root of r to the 5, which I can then simplify as 4th root of r to the 4 times 4th root of r. Now the 4th root of r to the 4 divided by 4 is 1, so that's just r times the 4th root of r. All right, problem H. We have the square root of 7 to the 3rd power divided by square root of 7. So remember, when there is a radical in your problem, you always start out by rewriting a problem with rational exponents. So I could rewrite this as 7 to the 3/2 power divided by 7 to the 1/2 power. Now you use your properties of exponents. This would be the same thing as 7 to the 3/2 minus 1/2, because to divide like bases, we subtract the powers. So 3/2 minus 1/2 is 7 to the 2/2, which is just 7 to the 1. So our final answer here is just 7. All right. Problem I. We have the square root of m cubed divided by the 4th root of m to the 5 power. So I'll start out by rewriting with rational exponents. So this would be m to the 3/2 divided by m to the 5/4. So to divide problems with like bases, we subtract the powers. So 3/2 minus 5/4, and we get the 1/4 power. So m to the 1/4 power. And our last step is we rewrite it as a radical. So 4th root of m to the 1 power, which cannot be simplified any further. All right, in problem J, we have 4 to the 3/5 power raised to the negative 5/6 power. So to raise a power to another power, we multiply the exponents. So this would be the same thing as 4 to the negative 15/30 power, which is the same thing as 4 to the negative 1/2 power. And I could remember, when you have a negative exponent, you rewrite it as 1/4 to the 1/2, positive 1/2 power. And then rewrite that as a radical, which would be 1/4. And 1/4 would be 1/2. All right, problem K. We have the 4th root of x to the 10 power. So I'm going to start off by rewriting that as, as x to the 10 over 4 power, which is the same thing as x to the 5 over 2 power, which is the same thing as square root of x to the 5. Now that can be simplified because we could rewrite that as square root of x to the 4 times square root of x to the 1, because 4 plus 1 gives us 5. Now, the square root of x to the 4 divided by 2, gives me x squared, and then we have square root x. All right. In problem I, we have the square root, or excuse me, not the square root, the fourth root of 25m squared. So I could rewrite this as 25 to the 1/4 power times m to the 2/4 power. So to rewrite this as, I don't think this one is going to simplify at all. No. So this one is this is the final answer for this one. Fourth root of 25m squared. And that concludes today's lesson on the relationship between rational exponents and nth root radicals.